Hey everyone, this week we will be going over a metric known as wRAA, which is weighted runs above average. And I have this article from Fangraphs from 2010. I will leave a link of it in the description so you can learn more about it. But it measures the number of offensive runs a player contributes to their team compared to the average player. Since baseball is based on scoring runs, this is a great metric to measure how many more runs above the average, which is 0, compared to the rest of your team. So you can definitely see and measure how valuable someone is at the college level and how valuable someone is compared to the rest of their teammates. We won't go into the rest of their teammates, but we'll measure how someone invaluable is in terms of weighted runs above average. And it's a counting metric, which is something that I like because that way you don't see any skewness. You see something over time where you'll have a higher weighted runs above average because you're getting more plate appearances. Things along those lines. And this is how you calculate it. It's very simple. wOBA minus league wOBA divided by the wOBA scale. And if you didn't watch my video last week of how to calculate wOBA, please do before you continue on in this video. That video will help you show how to calculate wOBA and get these other metrics like the league wOBA and the wOBA scale in Division I baseball. So, let's begin by loading in our libraries, Baseball R and Tidyverse. So we'll load both of these in. And it gets both of them in. There we go. And then I will, again, attach it to my GitHub, and my GitHub will be in the link in the description below, where you can access these two CSV files. Again, if you haven't watched my previous video on wOBA, please do watch it. You can access the one of the CSV files in there as well as calculate wOBA. But we'll call two different CSV files. So first we'll call batters, and we'll say batters read CSV, and we'll say sample batters.csv, which is the CSV file that I will attach in my GitHub. So we'll load that in there, and then as well as the NCAA Guts page, which is again another CSV file that I will attach for you so you can access. So read CSV, NCAA Guts.csv, strings as factors equals false. So read that in there as well. And we'll look in the data frame. So the data frame has various players from various years, from 2013 to 2019. Some very household names. You see Chris Bryant, AJ Reed, Kyle Schwarber, Hunter Dozier. Definitely some guys. And the columns that we have are player, school conference year, school year, position, games played, plate appearances at bats, batting average, OBP, slugging, runs, hits, doubles, triples, home runs, RBIs, total bases, walks, strikeouts, hit by pitches, sacrifice flies, sacrifice hits, double plays, intentional walks, and wOBA, which is what we'll be using to get that data in order to get the weighted runs above average calculation. Now, what I'll do is just remove unnecessary items from the NCAA Guts page. So the NCAA Guts equals NCAA Guts piping operator, the %sign arrow, forward arrow %sign, select from the dplyr package, which is under Tidyverse, and then we'll select year, division, wOBA, wOBA scale, the weights, each linear weight, so you can see that again. Watch the wOBA video if you haven't already. You'll be able to understand that a little bit more. And then runs per win converter, which is the basis to use for getting batting runs in terms of obtaining wins above replacement, or WAR, which is a metric that kind of encapsulates a player's total value to his team. So we can kind of get the batting section of WAR from this video, because we'll have the weighted runs above average, which is a function of WAR, but We won't have other metrics, but that's fine. We can still have basically a non-adjusted batting runs, if that makes sense. So, and then we'll rename League WOBA as WOBA, so that way we don't have to deal with duplicate columns. So we'll remove that, and now we'll continue on, and we'll say batters equals, we'll do a left join, which is under the dplyr package. It's a common SQL code where we'll take every observation in batters and then join it by the matching columns or the matching rows of NCAA Guts. And how we do that is we'll say left join batters, and then the Y is NCAA Guts, and we'll say by equals in quotes year to refer to the year column. So that way we have that information as well. So we go all the way here. We'll have League WOBA, WOBA scale, the linear weights of walks, hit by pitches, singles, double, triples, and home runs, and then the runs per win converter, which again I calculated. I will go into a little bit more later on how to calculate that, but as of right now, we're just going to be focusing on League WOBA and WOBA scale. Now, we are going to create a function, but this time it's going to look a little different than last week. Instead of calling a data frame, I'm going to call each argument for the function. So again, from earlier, we saw that the formula for weighted runs above average is WOBA minus League WOBA divided by the WOBA scale times plate appearances. So this time we're going to create a function that asks for all of those arguments. So WOBA, League WOBA, scale, and plate appearances. So that being said, we're going to hit enter, and I'll break it down. So get wRAA is the name of the function. We'll call function, and then these are the 4 arguments, like I said earlier. And between the squiggly brackets are what you want the function to do. And in this case, we will create the weighted runs above average formula by rounding WOBA minus League WOBA divided by the WOBA scale times plate appearance to 1 decimal point. So now, how you can add that to our column or our data frame is say batters equals batters, piping operator, mutate under the dplyr package, which is adding a new column, and we'll say mutate wRAA, which is weighted runs above average, get wRAA, and then insert the argument. So WOBA equals WOBA, League WOBA equals League WOBA, scale equals WOBA underscore scale, as that's the column name, and then PA equals PA. And we can run this, and we can kind of see how many weighted runs above average some of these players are. So someone like Chris Bryant, who had third player in this row, had a 64.7 weighted runs above average. So that means among his teammates, he was 64.7 runs better over the course of the 2013 season. That's wild. That shows how great of a player he is. Now let's kind of show kind of the top 10. So we'll say batters equals batters, arrange, and now usually I just say descending, but another way to do this is you put a negative, and you'll say arrange negative, and we'll say weighted runs above average, and then we'll say select, we'll say year, player, school, and then wRAA, and then from the dplyr package also top n, which is just the top number, so we specify 10. Actually, we'll just say batters piping operator. We don't want to create a new data frame. And we can see, selecting by wRAA, weighted runs above average, Chris Bryant was the best in the span from 2013 to 2019. Adley Rutschman was number 2 at 62.1. Aside from those two, from 2013 on, those are the only two that had 60 or more weighted runs above average compared to their team. which is, again, really, really showcases how great a player was to the rest of their team. Brent Rooker in 2017 with Mississippi State. Kyle Lewis in the Mariners org. DJ Peterson, I think he's also in the Mariners org. Andrew Vaughn with the White Sox. AJ Reed has bounced around a few teams. Devlin Granberg, who was recently drafted, I can't remember who. And then Nick Gonzalez, who's probably going to be a top draft pick in this upcoming shortened draft. So this way you can see how valuable one player was for their team, and guys like Chris Bryant and Adley Rutschman were head above shoulders compared to the rest of their team. Now I want to create kind of a fun plot for this table. That way we can kind of create a visualization and add more effect to it. So what I'll do now is I'll showcase kind of a package that allows you to get NCAA colors and then create a plot. So the package that I'm referring to is NCAA Hoopar. Is created by Luke Benz. Highly recommend his work and highly recommend NCAA Hoopar if you're into playing around with college basketball data. And the way to install this is through DevTools, install GitHub, and then this is his GitHub. But since I already have it installed on my machine, I don't need to reinstall it, so I can comment that out. And now we'll go to library. Once you do have it installed, call library NCAA Hoopar. And now we can get from that NCAA Hoopar package an NCAA colors. And with that being said, we can get colors of these teams here and even logos of these teams. So how I did that was I said colors equals NCAA colors, and then we wanted to rename school for NCAA name. That way we can merge it, and it's a lot easier. So we'll say colors, run this. Now we'll say batters equals left join batters colors by school. Again, I mentioned that earlier, left join, keeping all the data in the batters column and then merging with the colors in from the right hand side of the table by school. So we'll run this. We're going to create a data frame called top 10, and how you do that is we'll say top 10 equals batters, and then piping operator mutate, and what we're going to do is create player year. That way if there's any duplicates, as you can see here, Andrew Vaughn did it and was top 10 in weighted runs above average for 2 consecutive years. So we don't want him to we don't want the plot to correctly or incorrectly display Andrew Vaughn's weighted runs above average total. So we'll say player year, and then we'll do a paste 0. We'll take the player name with a dash and then the year. And then we will arrange again by highest to lowest weighted runs above average. And then we will select year, player year, school, primary color, logo URL, and weighted runs above average. And from that NCAA colors package that we loaded in, we can have that. And then Dallas Baptist had a missing color and logo, so simply how to replace that through the tidyverse package in tidyr. Again, top 10, top n equals 10, piping operator, and then we'll say replace NA list primary color equals, this is I think the red color of Dallas Baptist, and then this is their logo URL. So top 10 batters, mutate player year equals space 0, player year, arrange weighted runs above average, select year, player year, school, primary color, logo URL, weighted runs above average, top 10, and then piping operator, replace NA with that stuff. And then as well as the San Diego logo was incorrect. So what I did was I said top 10, that $sign referring to the column name of logo URL, and then I did an if-else statement where top 10 school, if top 10 school equals San Diego, then replace it with this URL, the correct one. Otherwise, keep it as the same. So we will run this stuff, and then we will get into our final plot. We have kind of code already written here, but I will break this down for you. First, if you don't have a GG image installed on your machine, please install it by install.packages.ggimage. I used this in a previous video, but we're going to check this out. So now we're going to call it through the Tidyverse package. There's a package called ggplot, which is very useful for plotting graphics. So ggplot, and then the data that we request is top 10, and then the aesthetic, which is AES, and then we'll do an x equals, and then reorder comes in here, where we are going to reorder the player name by the weighted runs above average. So that way the bar chart will show from greatest to smallest, and then y equals weighted runs above average, the plus sign to indicate more code, geom col, which is again like a bar chart, and we'll say fill equals top 10 primary color, plus theme, legend position none, which that essentially means we're going to remove the legend, plus geom image, and then image equals top 10 $ logo URL, and then the aspect ratio, ASP, is 16:9, and then we're going to nudge y equals -10. That way the logo will be between the bottom of the bar chart and the top of the bar of that chart. And then our labels, xlab equals player and year, and then y label is runs above average, weighted runs above average. And then our geom text, that way we have a number displayed as well. Aesthetic label equals weighted runs above average. And then our vertical adjustment is just moving it up a little bit so it's slightly above the top of the bar, just -0.2. Just play around with it. That's how I arrived to that number. And then font face equals bold, which essentially we want it in bold font. And then our GG title, top 10 weighted runs above average from 2013 to 2019 in D1 baseball. So we will run all of this at once. Give it a second or two to load, and then you can kind of see right here how visually aesthetic it looks. So I will zoom it in for you, and we will look at it some more. That being said, we can see visually the number of the weighted runs above average above the bar, and then somewhere in between the top of the bar and the bottom of the bar, you can see the logo: San Diego, Oregon State, Mississippi State, Mercer, New Mexico, Cal, Kentucky, Cal again, Dallas Baptist, New Mexico State, and then we can also see the player name and the year. So pretty fun stuff to visualize. Now, what we'll do is create kind of a non-adjusted batting runs column. And how we'll do that is essentially what you do for the non-adjusted batting runs, a function of getting those batting runs for the wins above replacement in terms of if you want to calculate WAR at the college level. We will say this. We will say batters equals batters, piping operator, mutate, once again, and this time we'll just say non-ADJ, which is adjusted, then batting runs, and we'll say weighted runs above average divided by runs win. And like I said, we'll get to that runs to win converter and how I calculated that. So first I will add a round function to round it to just 1 decimal place. So we'll run this, and then I'll just copy and paste this code and just replace it with non-adjusted batting runs. So batters, piping operator, arranged from the dplyr package, which the negative means we want the best of the best. So negative means descending. That's another way to say it. So negative, and then non-adjusted batting runs. We'll say the same thing. Non-adjusted batting runs. We'll run this, and we can see that pretty much it's along the same lines of the wRAA, where except DJ Peterson in 2013, there was a pretty low runs to win converter, so he actually had more non-adjusted batting runs. So in essence, you could say without defense and base running, Chris Bryant was a 5.8 win player for the University of San Diego in 2013. You can say that and basically base it off of, we'll see how many games he played. So in 62 games, he accumulated 5.8 WAR, which then if you kind of increase it to a major league season, he's over a 10-win player for sure. He's up near 12 or 13 wins above replacement, if we're just saying for batting runs only that aren't adjusted. So this is really cool to think about, and you can kind of see how valuable a player was to their specific team. Based on this Fangraphs article, again, I will leave this article also, as well as the weighted runs above average article, in the description. This is how I calculated runs per win. Simply 9 times, in this case, instead of MLB, it will be Division I runs scored divided by Division I innings pitched. And I replaced any 1/3 or 2/3 of an inning with .333 and .667 respectively, so that way it was accurately calculated. And essentially what this does is gives us the runs per win converter to be able to convert runs into wins to get to that wins above replacement metric. Thanks for watching. Hope you enjoyed this video. If you did, please like and subscribe for future content. Next week, we're going to go into some advanced pitching metrics to use at the college baseball level. Thanks for watching and have a great day.